Hey there, Joel here and welcome to my channel Math World. I hope you watched the previous video on the chapter probability, where in the end I explained to you that probability of a number cannot exceed 1 nor it can go below 0. So it lies always between 0 and 1. If any calculation gives you any number apart from these, then please do recheck. So it can't be minus 3, or it can be 4, it can be 5, it can be 6. Okay, it can be anything between 0 to 1. Now, if two coins are tossed at the same time, then find the probability of getting at least one head. Okay, so what is happening? There are two coins that are being tossed. Okay, now what are we asking? What is the probability of getting at least one head? Okay, so when you throw two coins on top, they will end up, how is like this. They can be either first one head, second one also head, or it can be first one tail, second one tail, or it can be first one head, second one tail, or it can be the first one tail and second one head. There can't be any other option. Okay, so these are the possible options that can happen. Okay, now what are we requiring? We require only at least one head, right? So these are all the cases when at least one head is possible. Okay, in the first case both of them are head, but we want at least one. So 1, 2 and 3. Out of all these options of four options, 3 options are such where at least one head is possible. So the probability will be favorable outcomes. Favorable is nothing but what you actually want upon total outcomes. So favorable outcomes are 3, total outcomes are 4. So 3 upon 4 is the probability for getting at least one head. Okay, I hope you are clear with this. Let us move on with another problem. Now, a deck of playing cards is well shuffled. So shuffled, and if one card is drawn at random, so I just place my finger and remove one card, find the probability of getting a black colored card or a second one, a face card. So let's look at it one by one. Here I have a deck of cards. Okay, and from that there is normally ace of flower, ace of diamond, ace of heart and ace of spade. Okay, and then all these cards continue. Okay, so it can be 2, then 3, then 4, then 5, 6, 7, 8, 9, 10, then jack, queen, king. This is entire set of one deck of card. Okay, how many cards? Total 52 playing cards. Okay, and in each deck there are 4 suits. Okay, you need to remember these words because they're going to help you to solve problems. So okay, suits are nothing but the color, one set of them. Okay, so the set of flowers is one suit, set of diamonds is another one, set of hearts is the third one, and set of spades is the fourth one. So there are 4 suits, all of them comprising of 13 cards. Okay, so 13 multiplied by 4 gives you 52. Okay, now what are we looking out for? First of all, we are looking just for a black colored card. So we'll just mark all the black colored cards possible. So they are, okay, all these, right? The entire suit of flower and the entire suit of spade is nothing but black color cards. Okay, so how many there will be? 13 and 13, total becomes 26. So when we are calculating the probability of a black colored card, we are looking at number of black colored cards, which is my favorable outcome, that is what I want, upon the total cards or total outcomes. So here it becomes 26 upon 52. That's the probability. You can divide those two numbers and get a lower fraction. You don't have to divide it so that you get answers in decimals. Please do not waste time doing that calculation. You can divide it to get a smaller fraction, but don't divide it to a point that you are going to find answers in 0.00 extra marks padpa nahi. Okay, so just leave it to a smaller fraction. Next is a face card. A face card is nothing but if you have that entire deck, there are some jack, queen and king, right? They have a face on it, right? So that's a face card. So how many are there like that? All these are face cards. Okay, so in total 3 and 4 suits. So 3 4s becomes 12. So probability of getting a face color card, okay, a face card, not a black card, a face card is number of face cards upon total number of cards. So 12 upon 52. Again, you need to divide it to a smaller fraction and that's it. Next, from a well shuffled deck of playing cards, a card is drawn at random and find the probability that it is a king. So let us have the entire set of cards. And what are we looking at for? We are looking for a king, right? How many are there? 4 kings in total. So probability of getting a king is number of king cards upon total number of cards, which is 4 upon 52, and when you cancel it, it will become 1 upon 13. I hope you are understanding and with me. If you are still having a doubt how to go about, please rewind the video, watch the video one more time, and I'm sure these doubts will be cleared. Next, a black face card. So I'm looking for a face card which is black in color. Okay, so these are the possibilities. So probability of getting a black face card is nothing but number of black face cards or favorable outcomes upon total outcomes, which becomes 6 upon 52. Next, only numbers, right? So out of the entire set, we are looking at only numbers, and here's a thing that you need to remember. A number of times, students think like, okay, 1 2 3 4 5 6 7 8 9 10 11 12 13, and if I remove jack, queen and king, so 10. But pay a close attention. We are not having 1 of flower or 1 of heart or 1 of diamond. We have ace, which is not a number card. So when you do that, the number cards are only this, starting from 2 till 10, and the total becomes 36 upon 52. Okay, so please pay attention to this when you are thinking of all these options. Keep in mind the entire suit and then you choose those cards, because if you just try to probability, easy chapter, tension nothing, these are the kind of mistakes that happen. So pay attention to what you are doing, okay, and rethink and then write. So 36 upon 52, you can divide it to a lower fraction. Next, 5 cards. Okay, this is not directly now normal playing cards, but 5 cards are numbered as 1 2 3 4 5 and are put in a box and mixed thoroughly. Okay, what is the probability of getting prime number when one card is picked at random? So 5 cards are numbered 1 2 3 4 5, and we have a bag. We are taking all those cards and putting them in the bag and then mixing them. Okay, and then one card is picked. Now when you pick that card, what is the probability that this card is a prime number? Now to tell, what's the formula? Probability of getting a prime number is number of prime numbers upon total number, right? Total number 5, but how many prime numbers are there? So for this, you should know what are prime numbers. Okay, so let me not explain you what are prime numbers, because you should know them by now. Okay, 2, 3 and 5 are prime numbers over there. Okay, so if you really want to know, then those numbers, okay, which you need to multiply by itself to get that number. For example, I need to take 2 and multiply it by 1 to get the answer 2. There are no ways I can get 2 if I multiply 2 different numbers, right? But on the other hand, if I want 4, I can get 4 when I multiply it by itself. So 4 multiplied by 1 gives me 4, or I can multiply 2 multiplied by 2 to get 4, right? So 4 is not a prime number, it is a composite number. So only those numbers which you need to multiply by itself to get that as an answer, then those are prime numbers. Now you will say 1 also is the case, right? So 1 is not a prime nor a composite number. So since we know which are the prime numbers now, it's very simple. So 2, 3 and 5. So how many total numbers? Favorable outcomes are 3 upon 5 numbers, right? So total number 5. So 3 upon 5 is my answer. Next, a dice is thrown once. Okay, so you have a dice and then I throw it once. What is the probability that the number appearing on top of the dice is a perfect square? So for this, you should know what is a perfect square to solve probability questions. Okay, so one dice is thrown and number of perfect squares are number 1 and number 4, which are there on the dice. Okay, so number 1 and number 4. 2 upon 6, which becomes 1 upon 3. Then multiples of 3, any number which is multiple of 3 can be considered there. So 3 is a multiple and 6 is a multiple. No other number is a multiple of 3 on a dice. Okay, so it becomes 2 upon 6 again, and which is 1 upon 3. Next, okay, we are going a little bit more advanced in solving this problem, so pay attention. Okay, a bag contains 4 red balls, 7 black, 5 green. Okay, all these balls are taken and they're put in maybe a bag. A ball is picked at random. Okay, so you put a hand and remove one ball from there. What is the probability of getting a red color ball? So we'll put them in the bag. Okay, and now we are finding what is the probability of getting a red color ball. So first of all, you should know what's the favorable outcome. What do I want? I want a red color ball. How many are there? In total 4. Okay, so but when you're putting your hand inside the bag to remove one ball, are there only red color? No, there are so many other colors, right? So what is the total number of balls that have been put? So once you mix and remove them, total number of balls are 16. You want one red color ball out of 4, right? So 4 upon 16, and that will be your answer. Not a green. So when I say not a green color, red can be a color which is not green. Black also is a color which is not green, right? So there are 2 set of colors. So 4 plus 7 total becomes 11. All these 11 color balls are not green, right? They're different colors. So 11 upon 16. 16 is nothing but the total number of balls that are there. So that's how I get 11 upon 16. If you can divide the fraction to a smaller fraction, please do it. Otherwise, they will just cut half marks for no reason. So avoid doing such mistakes. I hope with this you are clear with the chapter probability. And probability is actually a simple chapter, but it can be complicated and it can be made very difficult by giving you various options. There can be options like, telling you that I'm picking a piece from chessboard, and there are so many pieces. First of all, you should know what kind of pieces are there, how many are there. So then it becomes difficult. If you have never heard about chess, never played chess in your life, then you will not know. So this becomes the difficulty. Or it can be, in this case, like how there were questions like prime numbers, composite numbers, perfect square, perfect cubes, all these numbers, odd numbers, even numbers. So if you don't know them, then probability becomes difficult. Otherwise, it's very, very, very easy. I hope you have understood the main idea of how to solve probability questions. If you did, then please don't forget to hit that like button. That gives me motivation to put up these videos. Okay, and if you haven't subscribed, then please click on the subscribe button and press the bell icon for updates of new videos. Till then, take care, and If you really enjoyed the lesson, then help someone else to enjoy it and share this video. Till then, take care and bye bye. God bless you.